If you have an inequality, a shaded region in two dimensions, and you're given the equation of the border, then the question that's asking for the inequality of this is really like a multiple choice question. The answer could be either one of these four. X plus y is bigger than negative 1. It could be x plus y less than negative 1, or x plus y less or equal to negative 1, or x plus y bigger or equal to negative 1. And immediately these last two are ruled out because these would have been a solid line in the solid line border, whereas you see that the border is a dotted line, right? So this is dotted. So it's either one of these strict inequalities. Now, so how do you figure out which one's which? Well, the way you do it is by noticing that, say, 0, 0 right here is part of that shaded region. So any of these which has 0, 0 included will be the answer. So here's the question. Is 0, 0 in the solution set of x plus y bigger than negative 1? And how do you answer? Well, you put 0 plus 0, because 0, 0 means this is the value of x and y, right? X is 0 and y is 0. That's what this means. So you plug in 0 for x and 0 for y, and if this is bigger than negative 1, then you would have 0 bigger than negative 1. This is true, right? So if it's true, then the answer is yes. Okay. On the other hand, note that if you plug in 0, 0 into the second equation, then you get 0 plus 0 less than negative 1, which is saying that 0 is less than negative 1. This is false, right? So from this consideration, we know that this is a no-no, whereas this is yes. Okay, so the answer to this would be that you have x plus y strictly greater than negative 1. That's how you answer. Now, there is something called the standard form. Standard form is when you solve this inequality for y. So if you just subtract x both sides, and you get the standard form which says y is bigger than negative x minus 1. That would be the standard form of this answer, and either one would be the correct answer. You could have answered in this form or this form. Either one will be considered as a correct answer. But if the question is asking for what is this inequality in standard form, then in the case you should really answer it like this. Okay. Now, how do you actually draw these inequalities? Well, so suppose you're given this question, 2x plus 3y is less or equal to 8. So as we have seen before, we first need to identify the line equation first. So before being able to draw this inequality, you first have to figure out what it is. What's the line that would give you the boundary? Okay, so when is it equal, not like strict, not inequality, and when is it equal? Okay, instead of thinking about the inequality, equality is a lot easier to think. Okay, so we think about this, and so it means you have to draw the equation of lines. And it turns out that when you try to draw the equation of lines, the easiest one to do is to use x and y intercepts. Now this isn't always the best method, because sometimes if the line passes through the origin, then your x and y intercept just become 0 for both. In that case, you have to plug in other points. You may have to make tables and stuff like that. But in most cases, the line wouldn't pass these origin 0, 0, and this method would work. Okay. So how do you get the x-intercept? To get the x-intercept, you set y as 0, right? So you put y as 0, you get 2x plus 3 times 0 equal to 8. And therefore 2x, 3 times 0 is 0, so you end up with 2x equal to 8, which means x equal to 4. How about the y-intercept? To get the y-intercept, you set x equal to 0, and therefore 2 times 0 plus 3 times y equals to 8, and that's just 0, so dividing by 3 gives you y equals to 8 over 3. Okay, now we can draw the graph. The graph must pass through 4, 1, 2, 3, 4 for the x, and the y-intercept is 1, 2, well this is 2 and 2/3, right? If you divide 8 by 3, 3 times 2 is 6, subtract, so you get 2 as the remainder, so it's 2 and 2/3, so it's 1, 2, this is 3, and 2/3 is somewhere here. Okay, so you're looking for a line that passes through these 2 points, and therefore the line must be this one. Now you also have to be careful when you draw the line, since this is an inequality with equation sign under it. In this case, we draw a solid line. Now, had this been a strict inequality, like strictly less than 8, in that case, you should be drawing this as dotted line. We'll do another example like that. Okay. All right. So we know that the border is this. Then, if this is the border, what is the solution set that this is satisfied? Well, we can try numbers like does 1, 1 fall into the solution set? If you plug in 1 and 1, what do you get? 2 times 1 plus 3 times 1, that's 5. 5 is indeed less than 8. So 1 is included, right? On the other hand, if you put something like 4, 4, if you plug in 4, 4, what happens? 4 times 2 is 8, 4 times 3 is 12, 12 plus 8 is 20. That's way more than 8, so it doesn't work. So this doesn't work, whereas this works. And if you keep plugging in different numbers, you'll see that indeed everything that's on this side, when you plug them in, it's going to work, whereas if you pick anything that's on this side, it's not going to work. So the answer is that it must be this side. Okay. Now, this will be actually what's going to happen in general. If you have an inequality where the border is the line equation, then the inequality will first be divided. The border will first be the line, and once you have the line, you just have to pick which side of the border it is. And you can easily check that by just plugging in 0, 0 in most cases. Just plug in 0, 0. If it works, then it's the side that contains 0, 0. If it doesn't work, it's the other side. That's how you can figure it out. Another possibility is to plug in like 1, 1. If 0, 0 sometimes doesn't give you the result you want, in that case, put 1, 1. I can't think of, I guess there's one example where 0, 0 nor 1, 1 wouldn't work. Then you would try 1, 2. And any example that you can come up with, if you try 0, 0 or 1, 2 or 1, 1, one of those three should definitely give you a conclusive result. Okay, so that's what you should do. Let's do another example. So here in this case, first the equation for the boundary is 5x minus 3y equals to 9. So replace the inequality by equality, see what graph it has. And for x-intercept, you set y as 0. So setting the y as 0 just gives you 5x equals to 9 because y becomes 0. So that gives you x. If you divide both sides by 5, you get 9 over 5. On the other hand, y-intercept would be setting x as 0, so you get 0 minus 3y equals to 9. So you divide both sides by a negative 3, so that gives you y equals to 9 divided by 3 is 3, but there's a minus, so it must be negative 3. Okay. And then you plot those two numbers. 9 over 5 is like a little less than 10. 10 over 5, which is 2, right? 10 over 5 is 2. 9 over 5 is less than 10, so it's something close to 2. So if this is 2, this would be 9 over 5. And then negative 3 would be 1, 2, 3, negative 3 right here. And you have these 2 points, so you should connect them. But wait, this is a strict inequality, so you shouldn't be drawing solid lines, but you should be drawing dotted lines. Okay, and then it's either this side or that side, so we choose 0, 0 and see if it works. So what happens if at 0, 0, what happens at 0, 0 is 5 times 0 minus 3 times 0 bigger than 9. Is 0 bigger than 9? No, it's not true. This is false. So 0, 0 is not part of the domain, therefore the shaded area should be the one that's not including 0, 0. So therefore the answer should be here. Okay, so you just shade using, you can shade it like this, you can shade it in some other direction. Just shade it, and that's the answer. Now, what if you have more than one inequality? What if you have both of them put together? What would that give us? So in our case, you would get, let's see, we already know that here's 9 over 5, and this is like negative 3, and this is like that. And you have one direction, it's this side, for this one. We just did it. And this one was from the first example, right? It's this first example where it's 8 over 3 and 4. So you would have 8 over 3 is bigger than 9. It's 2 point something something. So I'll just say 8 over 3 is somewhere here. Oh, sorry. Should have been 4 and 8 over 3. So let's look at 4 and 8 over 3. So you need 4 and 8 over 3. And then you draw this line. And the shaded area must be, we had it below, right? So we should be shading here. Let's use a different color so it's less confusing. So the shaded area is here. So what gives? Well, if you compare the two, the only region that would satisfy both of them would be, it will have this side, and this side will be like that, right? And it will be this. This would be the region that will satisfy both inequalities. Okay. Now I want to throw in some horizontal or vertical lines. So here's an example. We still work with the same inequality because I want to save some time. You should practice with other inequalities too. So this one, here's negative 3, here's 9 over 5, and then it's a dotted line. We know that's this side, right? Now, y less or equals to 2, what is this? Well, first, think about y equals to 2. Y equals to 2, if y is a single value, you know that it's a horizontal line, right? So you have this horizontal line, and then think about 0, 0. 0, 0 means x is 0 and y is 0. So at 0, 0, if you plug in 0 into y, this is indeed true, right? So if you have y less or equals to 2, you're going to get this as your shaded area. So what's going to happen is First, the first inequality would be this, whereas the second inequality will be right here, and it will be below, so it will be below, and therefore the overlapping part of this would be, let me draw in another color, would be this dotted line and this solid, and it'll be this. Oh, there's something I forgot. When you do these, you must figure out the intersecting point just to make sure that, because a lot of times when this is used in some applied situation, this point where they meet becomes a very important point. So let's try to figure this out. What is this point? This point is where 5x minus 3y and 2x plus 3y meet. Okay, so we have to solve this. And how do you solve it? Here there's a simple way to solve. Just add them. 5x plus 2x will be 7x. Negative 3y plus 3y will be 0. 9 plus 8 will be 17. So x would be 17 divided by 7 after dividing by 7. And then once you have it, you should plug that into one of the equations. So let's plug it in here. 2 times 17 over 7 plus 3y is equal to 8. Then this would be 34 over 7 plus 3y equals to 8. Subtract 34 over 7. Then 3y would be, 8 is 56 over 7 minus 34 over 7, which is 22 over 7. So 3y is 22 over 7, and dividing by 3 just becomes 22 over 21. So this point here, you would find that it's 17 over 7 comma 22 over 21. Okay, so this is the coordinate. And in the same way, let's try it here. So in this case, we want to meet when y is 2 and also 5x minus 3y equals to 9, right? To figure out when they meet, since y is already 2, we just have to figure out what x is. So you solve for x when y is 2. And this is 5x minus 6 equal to 9. Adding 6 both sides gives you 5x equals to 15. Divided by 5, and you get x equal to 3. So this point will be 3 comma 2. Okay, what about vertical lines? Well, this one here, x equals to negative 1 is a vertical line, and here's negative 1. It's a line that passes through a negative 1, and be careful, it's a strict inequality, so you can't draw a solid line. You have to use a dotted line. And think about what happens if you plug in 0 comma 0, 0 into x and 0 into y. There's no y, so you only plug in 0 into x. So at 0 comma 0, you get 0 bigger than negative 1, which is indeed true. Right? So we see that you get this as the inequality. And since I already know that the first one gives you, here's 9 over 5, and this is negative 3, and dotted lines. And this is you have here, and also here. The overlapping part would be this part. Okay. All right. Now let's think about a word problem that would satisfy this. A company makes mixed nuts from almonds and pecans. The company's daily budget for raw ingredients is $1,000. Almonds are $4 per pound and pecans are $6 per pound. Let x be the amount of almonds and y be the amount of pecans, both in pounds. Write an inequality in standard form that models the situation. Okay, so if you have almonds and x pounds of almonds, how much is it? Well, if this doesn't uh, this doesn't become clear to you, you should try to think in terms of examples. So let's say you want to buy 4 pounds of almonds. Then how much money is it worth? Well, it's $4 per pound, and you have four of these, so it's going to be $16, right? So if you think about what just happened, you know that basically what's being done is that the the x pound of almonds would be 4x. And in the same way, if you have y pounds of pecans, then this would be 6y because it's $6 per pound. So what's the total cost here? 4x plus 6y would be the total cost. And you want this to be less or equals to $1,000, right? And that's it. Now, it doesn't end here because it says write an inequality in standard form. What is standard form? As I said, you have to solve this for y. So this is not yet the answer. You have to subtract 4x and then divide by 6. And you get y less or equals to negative 2/3 x because 4 over 6 reduces to 2/3. 1,000 over 6 reduces to 500 over 3. Okay. So I did this last part rather quickly, but if you do the calculation, you'll see that indeed this is the answer. So it's not that bad. The application problems in here most likely has the form something times x plus something times y, bigger or less than some number. So if you try those, you're going to quickly be able to write the answer.